Testing, testing. Very good. Excuse me. How are we all doing today? Excellent. As you can tell, I'm losing my voice a little bit. This started yesterday after my first talk, so forgive me. Apologies in advance for that. Not much I can do about it. I'm sitting here drinking hot tea, trying to stave off sounding like a frog as much as possible. My name is Spencer, and it's a pleasure to be back here in Poland for my fifth DevConf. This is a conference I always make every year because I think it's an absolutely amazing event, and I hope you've enjoyed it as much as I've enjoyed it. And I'm here to talk to you today about a little bit of a passion project. This is a very different kind of talk than I normally give. A lot of my talks are deeply technical and built to solve business problems, really built around how do you use technology to solve business problems. This talk is completely not that. It's a journey. This talk is a culmination of a journey to do something fun. And I hope you've enjoyed it as much as I enjoyed putting it together. I will say first, you'll hear me do that a lot. First things first, there is a content warning. There are clips of first-person shooters, so that if you're not comfortable with that, turn your head away, close your eyes. But I imagine, I'm going to guess that a decent portion of the audience has played a first-person shooter or actively plays first-person shooters. Let's see some hands. That's good. Out of curiosity, anybody play Escape from Tarkov? Okay, we got a few. All right, that's awesome. Well, awesome. Love to hear it. All right, well, first, a little bit of history about myself. I run a software consultancy. This is, so I do a lot of .NET and a lot of cloud. And unlike a lot of programmers that I've interacted with throughout my career, I did not start as a developer like when I was 10 years old, which is kind of funny because my mom is a COBOL programmer. And to this day is still a COBOL programmer. And I never got into programming until I did it professionally. So when a lot of people talk about things that they've done or projects that they've done early on where they were just trying to solve something fun, I've only done work professionally. So personal projects and side projects weren't really a thing that I did until I started really making a career out of software engineering. But 20 years ago, I wasn't doing like I said, I wasn't doing programming. I was in college, and I was playing games like Halo 1, Halo 2 when it was out on Xbox Live, which was a really awesome era, Call of Duty, and of course Counter-Strike 1.6, eventually Counter-Strike Source. This is my favorite picture from me from college. I like this one because it's just so ridiculously goofy. And I've kind of not lost this nerdiness to this day, although my hair is maybe a little better. I do want to point out that my favorite part of this picture, though, is the fact that I have a bottle of mustard on my desk because I guess I ate a lot of mustard with the things that I'd consumed. But my life these days, back then it was just college, had a girlfriend, and then I played video games. A lot of my time these days, like many people, is consumed by family, work, games, and watching other people play video games. And there's really only two games that I play with any frequency, which is Call of Duty Warzone and Escape from Tarkov. And really, nowadays, it's really just Escape from Tarkov because Warzone changed dramatically with Warzone 2, and it's not nearly as fun to play. Don't get me started on that. So besides playing video games, which is something I play Escape from Tarkov probably more often than I need to, more often than I should. But I also watch streamers, which is an extremely awesome form of entertainment. It's fun to watch people who are way better at the game than you play the game and be dominant in a way that I'm decent at FPS, but I'm not nearly as good as some of the people that I watch. And you could start with some of the more famous ones like Dr. Disrespect. That's probably the most well-known streamer that I watch. Other ones that are just Call of Duty streamers that are kind of goofy like Bobby Poff. And then we have this gentleman on the right. This is LVNDMARK. LVNDMARK is by far my favorite streamer. It's pretty much the only streamer that I watch for Escape from Tarkov. And if I'm not playing Escape from Tarkov and I'm not hanging out with my family, or even if I am hanging out with my family, I have LVNDMARK on. And I have LVNDMARK on because he's the most entertaining, which we'll talk about why I think that it does play into this project. But before we start diving into the project, for those who do not know Escape from Tarkov, we got to talk about it. So Escape from Tarkov is considered a first-person immersive tactical shooter. Immersive tactical shooter. All right, that was less broken. So the goal of the game is you spawn into a map, into a match called a raid. The raid has a fixed amount of time, and basically your goal is to run around, kill people, NPCs, as well as PMCs. Those are the other players in the game. And then looting. Looting is one of the most important mechanics because, much like a lot of RPGs, because this game has a lot of RPG elements, you have a stash. And that stash allows you to have equipment and really build up your kit and get into fights. So besides the looting, of course, there's the fighting, which are typically very short-lived fights. These are not usually prolonged fights like they are in like Call of Duty Warzone or something like that, or when you play in a game mode where you just instantly respawn. One of the most fun parts about this game is the fighting, and it gets really intense and really good. But that's the most important thing. The main two things, the fighting and the looting. Looting is really important to understand because you have a fixed amount of stuff in your stash. And all of the things that you build, all of the kits that you build in order to attack and get into a raid and survive the raid is built around the kit that you bring in. There's a selection of maps to choose from. This one in particular that I have highlighted is Reserve, which is my personal favorite by far. A lot of the popular ones are like Streets of Tarkov, Customs, and the maps look like this. They're not super big, but they are usually pretty extensive. This map is a map of the most popular one in the game, which is Customs. Customs is the most popular map to play on, especially if you're looking for PvP or player versus player fighting. And the thing that I have highlighted on these maps, you don't just go into a match and then you can just leave anytime you want and just take all the stuff that you've looted and just leave the match. That would be awesome. Well, actually, it wouldn't be because it would change the game fundamentally. When the highlighted things on these maps are extraction points. This is how you get out of the game. When you first spawn into the game, you'll notice two things at the top right. You'll notice a list of extracts. Those are places that you can get out of the map. Those are places where you are allowed to leave. You see some question marks there. Sometimes those extracts are open. Sometimes they're not. You'll also notice up here, there's a timer. You have 40 minutes in this particular match. All of the matches, the time is based on the map that you go into. In Customs, it's 40 minutes. And you have 40 minutes to get out of the raid. If you don't get out of the raid, you lose your stuff and you pretty much just die. You go MIA is what it's called, but you'll lose all the gear that you brought in and anything that you've collected. So this adds a lot of intensity to the game because not only do you have to pretty much literally fight your way out of the map, sometimes getting to an extract and getting out with good loot is quite an intense challenge. So you'll notice here that for new players especially, this is particularly difficult. I spent my first wipe, that is about a 6-month period where the servers are reset at the beginning of that period, and then you just build up your stash, and then they're reset again. Happens about every 6 months. When you first start playing Escape from Tarkov, there's a huge learning curve. There's a lot to learn about the game in particular and how about to survive in the game. And you'll use this as a new player a lot. This is a map. This is available, mapgenie.io, I believe. And you would basically hope that you're able to get your bearings enough to know where you are, and then figure out, based on these extracts here, how can I get out of the game? How can I get out with all the loot that I've collected? And looting is not just about looting from the environment. It's also about looting from other players. This is a fight that Landmark won. And when I say that you could lose your gear, oftentimes what happens is players take it. And that's part of the fun of the game is getting gear from other players and getting into those fights. And it's very satisfying at the end of the day to get out of those. That gives Tarkov a unique risk-reward component, which makes it especially fun to watch, especially when you're watching people who like to get into fights, like Landmark. Landmark is by far the most PvP-centric streamer that I watch. It's really the only one because he really focuses on PvP. So I've sped this clip up, but this is after he died, he had to start over. So I sped this clip up quite a bit. There's a lot of work that goes into picking a kit. Picking a gun, you have to pick a kind of ammo. Yes, there are different kinds of ammo, so a 9mm bullet can be very different from another kind of 9mm bullet, just like they are in real life. So what you pick and how you survive really plays, or really what you pick really plays into a risk-reward component that's really unique to other games. You can bring in lots of great gear and get killed by a player who's just has a Mosin and that's it. You could bring in a lot of nothing and then you could bring in a lot of nothing but a pistol and then luckily take out a player who has a lot of gear. So that makes it a lot of fun because you're able to kind of choose your own adventure. You can go in with a really bad kit and your chances of survival are low. You can go in with a good kit and your chances of survival go up, but you still could die and you can still lose your kit. So it makes it fun to watch. And by the way, death, it's not just the best players in the game never die. Death is a part of this game. Oh, I think I have it muted. Yes, I think I do. Here we go. That way we can hear the sound. So this is him getting into a fight in the reserve bunker. So he knows there's a player. And in this game, you die very quickly. It's over that quick. I mean, you could spend 40... I've spent almost all...
ammo didn't work there because I couldn't see his legs.
Oh.
I was hoping.
Oh, yeah. That was Landmark talking. It's a lot of fun because... but you could spend an entire time in a raid, get a lot of stuff, and then get killed by somebody at the end. You can also... But when you do survive and you have these really good moments, like this is a clip from me on a really intense map called Labs, which is incredibly PvP focused. It's really dark, and I'm sorry that it's dark, but I'm fighting about 3 different players. And as I mentioned, you get into these fights and you die very quickly. And in this case, I just happened to survive. That guy, I don't know how he lived on the ground. I saw somebody in that corner. I moved out of cover. I shot him, took him out, finished that guy off, and then turned around, and I don't know why I was aiming at the pillar. But it's moments like this that make Tarkov so much fun to play. There's a streamer called Dr. Lupo who plays this game, and he says, this is the only game that makes me feel anything, and that's why I love it. At the end of the raid, you have a kill screen. This is the number of kills that you've gotten. You could get 0 kills. You could just sneak around the map. You can go in night or day. You can go in, there's 2 different times that are going on, so playing at night is fun too. And you might just avoid all PvE and PvP combat, maybe if you're trying to do a quest or something. But at the end of the raid, you get a kill screen. This is the number, these are the players and the NPCs that you've killed. Scavs are NPCs that are just common throughout all maps, except Labs. And basically, they're just going around and they're just nuisances to PMCs. They're not very good, but they can be dangerous in the wrong situation. You'll notice that we have the names of some of the players. We have USEC and Bear here. When you get into Escape from Tarkov, you choose a faction, either USEC or Bear. So we know those are players, and we know those are players because they're leveled, because there is also a level indicator next to them. You'll notice that sometimes we get just question marks. We don't know who that player is. And that's because Landmark hasn't collected their dog tag. When you die in the game, you drop a dog tag. And you can pick it up. The other player can pick it up so they can know the name of the person that you killed. And if you don't know it, you just get that. So there's a lot of different information that I've kind of given at you. So before I talk about the project itself and how I consume this information from a technical perspective, how do I consume the streams in general? Sometimes I watch them live. Sometimes I'll put Landmark on while I'm cooking dinner. Sometimes I watch clips posted to YouTube. This is my favorite way of watching these things because usually the only clips they post to YouTube are the ones where there's a lot of fighting going on, which is really fun. But more often than not, I just go to past streams and just skip around until I find maps that I want to watch or raids that I want to watch. But it becomes kind of a chore because you might pick a bad raid. You might pick a raid where he's not gotten in any fights. It's really been useful lately because Landmark started posting his streams to YouTube, which has made it even more fun for me to watch because I'm not a big fan of Twitch as a platform and as a consumer of video. But YouTube, I definitely am. But again, I have a family, I have work, I have home responsibilities. I just don't want to have time to just skip around. It becomes cumbersome. Some raids that I play or raids that Landmark plays, he'll loot the entire time, which is not interesting content. And he won't encounter a single player. He might encounter a couple of scavs, but that's by and large not interesting to watch. Not to mention that not only do I like to watch the fighting in the game, I like to watch Landmark play on certain maps, specifically Reserve, because Reserve is by far my favorite map because of the concentration of loot, and you always get into fights. The map is just too small and action-packed to not encounter other players, which to me is the most fun of the game. So thus, this project was born. And I wanted to answer just a couple of simple things. How can I download a stream onto my computer, split it into different raids myself? and then watch the most action-packed ones on maps that I enjoy watching, like Reserve or Customs or Factory. And bonus, be able to know inside of each of those individual segments, where's the action taking place? Where's the action going on? One thing about this project is that, unlike the professional stuff that I do, it's a bit of a mess. There's a lot of brute forcing involved. You'll hear me things like, I just didn't want to spend the time doing it. Same thing. It's a risk-reward kind of thing, same as in my professional life. I wasn't chasing perfection. This is a side project, so perfection is not the goal. But you'll see all the different things and all the different decision points that I made to bring this project to life. So the goal of this project was not only to split up the raids so that I can watch the ones that I want to watch, but I can have fun applying my work skills to a personal thing, and I could probably learn something, and be able to apply very many various skills to one problem. There's a lot that goes into audio and video processing, a lot of which that I have experience in because one of my clients does a lot of audio call processing. So I was able to borrow from that experience, but by and large, I had to figure out a lot of the video stuff myself. The first step, getting a stream. That's the easiest. There's a YouTube. There is a NuGet, or not a NuGet. I'm sorry. There's a command line tool called YouTube-DL. YouTube DL is a tool that I love, and it doesn't just download from YouTube. It downloads from Vimeo or Twitch. You basically just point it to a URL, and it's usually that turnkey. It just downloads the rest, and it does the rest yourself. What you end up with, though, is because streams, their goal is to stay on for a decent part of the day so they can maximize their viewership, so they can get ad revenue, and they can get donations from people, and get people subscribing to their to them so they can get supported. So these streams often go a long time. Landmark often plays for 8 hours a day, which I love video games. But that seems like a crazy amount of time to play a video game. I think my brain would turn to mush. So the goal is to, because I have this 30 gigabyte video file, I only have audio and video information. When I'm playing the game, I have tools on my computer that will record individual matches for me. And then I can slow them down or speed them up. So I can either get clips for for something like this, like a presentation like this, or I can just, if I lost a fight, I can see what I could do to improve. And those tools are great because it'll tell me what map I played on, how many kills I got, whether or not I survived. And that's great. But I don't have access to that information. All I have access to is this stream. So it's kind of like looking at it through a window, right? Like there's all this telemetry data that if I had it locally on my machine, if I was running the raid, I could collect it all myself. But because I can't collect it, I only have this file. So the challenge was, how do I extract data from this video? So you're going to hear me talk about a combination of technologies that I use to make this happen. First and foremost, .NET. .NET is what I live and breathe. So a lot of what I wrote, a lot of the web components that I use to actually view the streams, I wrote those in Blazor. I used Entity Framework to store data about the individual raids. I used this as just an execution platform so that I could actually do the thing that I wanted to do. Do the thing that I wanted to do. I could have done it in a lot of different languages, but of course I chose C# because it's the most comfortable. Although by and large, I had to also learn a little bit about Python because machine learning tools are almost exclusively done using machine learning tools is almost exclusively done in Python, at least for the majority of people who use it. We have FFmpeg, which is in terms of its impact to the world, probably one of the greatest open source projects to ever be created. The significance of FFmpeg as an audio and video processing tool cannot be understated. Every single platform, YouTube, Vimeo, Twitch, they all use FFmpeg under the hood in some way. And you can use it to separate the audio from the video. So you just get an MP3, which is important when we'll talk about that. It could be used to just get a section of a video. It could be used to get individual frames from the video. And I used all of these in order to execute on this project. We have Tesseract OCR, which is pretty much managed by Google. It's been around for a long time. It's a machine learning based OCR, optical character recognition tool that I can use to read the actual information on the screen and translate that into data. We have Skia which is a .NET tool. It's an open source image library. And I wouldn't say a lot of people lately have started transitioning to it because image appropriately became at least partially a commercial product. So I use this as an opportunity, a low risk way to kind of learn something new about a framework that I didn't use often, which was Skia Sharp. And then we have Hugging Face, which isn't a technology, but in and of itself, but it is a website which is basically a published where you can publish a lot of machine learning models, and so you can see the reviews on them, how many downloads they've had. And there's a ton of them. There's ones for text to speech. There's ones for just audio recognition, which is the one I end up using, visual recognition. So those are really useful, really cool, and really helpful. It was a really helpful resource as I was learning some of this stuff. We're going to use these technologies to answer very simple questions. What raids did Landmark play in? What maps are those raids on? And what were the time codes? Very tricky, but certainly not impossible given all of the information within that video. How many kills did Landmark get in each raid? And if possible, what were the most intense moments? Essentially, I had to translate that file into a table like that, which might have 20 to 30 entries. That's it. That's the only thing that I'm interested in, because it gives me a lot of information. It gives me enough information. Is this a raid I want to consume? Is it on a map that I want to watch? What are the time codes for that? So that way I don't have to worry about skipping around. I can just have FFmpeg. I can cut those streams down into bite-sized video files, or at least skip around inside of a video web component. Then how many kills did you have? Is this something worth watching? I don't want to watch him loot. I want to watch him play. And then we have to translate that into some kind of, this is a screenshot of the, spoiler alert, it's a screenshot of the web application that I wrote in order to actually consume the stream. So I can look into an individual stream and look at a raid and go through all of the raids and go and seek and figure out which one of this giant stream, which ones do I want to watch. So the most important information, audio and video, is the visual information on the screen. Luckily, Tarkov is kind of a game that was bootstrapped. It's based from a company in Russia. So it's not like a lot of like Fortnite or Call of Duty, where there's a lot of animations and a lot's going on the screen. Relatively, before you get into the game, not a lot's happening. So it makes it a lot easier for somebody like me to consume. So this is the deployment screen. This is the screen you see for about 3 to 5 minutes before you actually get into a match. The most important information on this screen is this right here, the map name. It always is in that position. It always looks like that, which makes it very easy to consume. You could either teach a machine learning, like you could go all the way and go full bore, and I considered doing this, where I was just like, I'll just feed you a bunch of images and you'll tell me what map this is based on the images. I will train a separate machine learning model. I ultimately settled on OCR because it was a lot easier to do. It was a lot easier to accomplish. The other piece of information is the kill screen. Now this one is full of complication. Not only do we not know the names, I don't really care about the names of the players as much as I care about how many kills he had and how many of them were players. You'll notice here that he had 8, but here at the bottom, I know it's hard to see, there is a line. This is tabular data and you can scroll through it. So the reality is that if he doesn't scroll down this table, I don't know exactly the full amount of kills that he had, but it's more than likely that if he's having to scroll, I kind of don't care anyways, because I've gotten the information that I need from that screen to know if he's gotten 8 kills, that's actually quite a few. So that's pretty good. And the way I consume this data, Tesseract OCR, as I mentioned. So my goal was, again, finding ways to combine these technologies to solve the problem that I was seeking. How do I watch the most exciting raids? We got to start one thing at a time. So first things first. We take FFmpeg, extract every frame, not quite almost every frame. That would take a long time. But we extract each frame until we find something that's and then we read the frame, and then we see if Tesseract has something meaningful about that frame. So because it allows you to read text from images and it's ML based, I could have separately trained it to read and probably made like parsing this kill screen out a lot better. I ultimately didn't need to do that, but I did. It was a strong consideration as I was going through this project. The most important aspect of using Tesseract is understanding page segmentation modes. These are different modes that you can apply to Tesseract to actually read the data on the screen. And so a lot of what I had to do was experiment to find out which of these will most consistently parse out the information that I want, because the mode 0 behaves differently from mode 6. So a lot of them behave similarly, but some are better than others. So if I'm trying to get this data, this piece of data, it's very easy for me to take this and crop this frame down. And with a good amount of accuracy and choosing a page segmentation mode, which took some trial and error, and I'll show you how I went through that when we look at the code. It's very easy. You just take that segment of the screen. I don't even have to read the whole screen. I can tell Tesseract, hey, here's an image, but I only need you to read this region of it. That way I don't have to read the time has come, deploying to location, information that I simply do not need. It's just excess. Plus, it'll make Tesseract run faster. And even though this is a side project, performance is a consideration because it has to be at least reasonably fast in order for me to want to actually go through the process of actually downloading a stream and consuming it. The kill screen is a lot more complicated. But the one thing that I do first and foremost, is read this particular string right here. It says raid ended. So after I've figured out that we're on a map and that we're deploying to that map, I look for this string. I take those individual frames and I look for the string raid ended. That tells me that the raid is over, which I know sounds crazy. And it signals to me, okay, well, let's bump up the processing now. Let's try to process and read this whole thing, this whole screen, so that way we can try to figure out how many kills we had in the game. This was a tricky and required a lot of trial and error to kind of figure out. This was, when I first ran it through it, this is the information that I got from it. A lot of nonsense. I don't think there was a single word on here that really made sense in any way. There's no way I can look at this and determine, okay, this looks right, and this is kind of right. No, it was just all noise. But I've quickly learned about page segmentation modes and started iterating through which are the best ones that might suit my use case. And so I did end up picking one, and this one is a little better. So I'm going to read this for you because it's just a little difficult to read, but there is a scav whose name is, and I didn't pick this. This is just I didn't pick this on purpose, but their last name is C#. SISHARP. Shura C#. They have some of the scavs have some really funny names. And you can see that it actually read it. It didn't read the time code perfectly. The time codes were actually really nice to have if I'm able to read those. But we can see that we're starting to get some semblance of data. And the most important data to me is actually just the string scav. I don't need to know if it died if you died by a headshot or a leg shot. It really doesn't matter to me as much as it does was it a scav? Was it a USEC or bear, which tells me that it's a PMC? And including on the lines that have question marks where you don't know who extracted. You at least know that they were USEC or a bear, and you can see that down here that it's actually taking that string. Tesseract really likes to read these question marks as twos. Why, I don't know, but that's just the way it goes. So I had this problem with this image. It's actually fairly complex. If you as a human look at this, you're able to kind of read it and parse it and understand what's going on. It's not entirely impossible. But for a machine, there's actually some difficulties to it. You'll notice that this background, which I kind of think is a location on customs, is kind of like this window view. And it looks really nice, and it kind of adds a nice shadow and adds some depth, but that's noise to a computer. That's noise to an OCR thing. That's information that it simply doesn't need to do its job. So I thought, what if I could have gone one of two ways. I could have gotten 100 kill screens and trained the model to figure out how to exactly teach Tesseract how to parse out the screen. But again, that would have taken a lot more effort, and the goal was not perfection. So I thought, as I was Googling around trying to solve this problem, I thought, what can I do to solve this? And I ended up image pre-processing turned out to be the answer to that question. And Skia in particular was the way that I did that. And shout out to ChatGPT, because I was able to figure out how to do things like make an image black and white, remove its color information using Skia. I didn't Google around for that. I just outputted code from ChatGPT, iterated over it with it until it worked, and then I could get something that was a black and white screen. And to my eyes, it does actually seem to parse it a little better. If I remove that color information, it does help in making it so that this screen is even more parsable. But then I thought, what if I inverted the image? Because I think that text is most commonly black text on white paper. And so if I invert the image, a lot of that information gets they just look like smudges, right? It just looks like a smudge. And what you end up with excuse me, what you end up with is something that I feel like after a lot of experimentation tended to be the most consistent way to do it. It tended to consistently because it would misread USEC or bear sometimes, and that was really important information. And it looks a little messier, but it actually is actually able to read the question marks now. It's actually able, whereas before it would have the number of kills that you have. It'd have these numbers without spaces. Now it's adding these with spaces. I thought about taking this even further. What if I increased the contrast and made this text really like black on white? Surprisingly, I didn't experiment with this for long because it didn't go very far. I think if I had spent more time with it and really focused on just making this text better, this text like more stand out more, I probably could have gotten a more consistent result from Tesseract. But I didn't do that because it simply just was a lot of time and I was reaching my image processing kind of techniques and I wanted to move on to other things. So we started with this, and again, we ended with this. It looks messy, and it is messy, and it doesn't look like it made much of an impact. But based on my experimentation, I determined that inverting and making the image black and white was absolutely the best way to get the most consistent results on a kill screen. But I didn't spend a huge amount of time chasing perfection. I simply didn't need to. So let's see it in action. Let's actually see some code. I'm actually going to, let's see, I'm going to turn this so that it mirrors. Mirror. And this should be good, because if I don't, I have to look behind me, and that's really not fun. Let's see. Let me try something real quick. I watched what this gentleman did. He turned this to, 24. And, yep, there it is. 24 hertz. There we go. I love it. 24 hertz, not great to watch video, but we're not at that point. So this is my project. So I'm going to start by running the actual scraper. And if I go to the program.cs and I zoom in, you see that it is just a mess. There's a lot. This is, again, not a perfection thing, but I'd essentially go through, I'd point it to a video, I'd start up I'd create a stream instance, something that I could save to a database. In this case, it was SQLite. SQLite is absolutely the right tool for this job. Didn't need anything more complicated than that. And then I started going through, and this is my code to actually go through each of them. And I used parallel.forEach. I used parallelism because reading frames and OCR, running all those, extracting those things is computationally just expensive. Period. There's no way around that. So parallel.forEach was a great way to just kind of add some parallelism, because if I run this thing, it will use all of my CPU time. And we'll take a look at what it outputs. Did I run that? Okay, good. I ran that one. Stream already exists. Overwrite. Well, I don't know that I want to overwrite it, but we'll go ahead and say yes. So this is where it's actually going in, and it's actually processing each of those frames. So right now, it's taking each of those individual frames. So I have it running about 15 seconds. If I tried to get every individual frame and process them, I think I calculated it out, it would take about 3 weeks. So I decided not to do that. But you can see as it's watching the video, it actually finds now a place where it's actually, and I started at 15 seconds so I could find a waiting to start raid screen. And then I bumped it down to 3 seconds. And I bumped it down to 3 seconds because at any time the deployment could happen, and I wanted to make sure that I captured that because a deployment is in about a 10-second window, so 3 seconds seemed appropriately aggressive. It runs fast enough. And you can see that we have a deploying screen. I actually forgot to show a screenshot of it. But there's a screen that says deploying, and it has a countdown timer, very dramatic. And when it's doing that countdown timer, it's saying, you're 5, 4, 3, 2, 1, and then you'll get into the raid. There's a big word, deploying. That's the word that I look for to know when the match starts. And it's probably gotten through and figured out at some point, okay, so right now the match is going on. And if you were to look here at the time code for this actual match, 1997, if I looked here and looked, you can see that right as I say deploying 1312. So we go to 1312. Scrubbing on this thing is not very accurate because these streams are so long. 12. So you can see that at about 1309, that's when we should start seeing the actual deployment screen. So there it is. And that's how I know the match is starting. So that's where I capture that start time code. That's where I signal to my thing, okay, hey, we know what map it is. We can see that you can very clearly see that it's customs. You see some unknowns, and we'll talk about that. But you can very see, like, if you take the biggest, the most common value of all of these things out of all the known maps, customs is definitely our map. And so we go down here, and you can see the match is still going on. This is actually a good one. This is actually a match where I'm assuming that he's getting into some fights and he's doing a lot of looting. So this is probably a match that I want to watch, but I won't know until I see the kill screen. And if I go down here to, let's see, file path equals path. Perfect. Okay, so this is where I do some frame analysis to figure out, okay, is the raid over? So at this point, we know that the raid has ended, and you'll see that I bump it down, and this is going through pretty fast. So I'm going to scroll up a little bit. So we know that the raid ends at 31:57 because there will be a screen that says raid over. Either he died or he got out, he extracted. And at that point, we know that the raid is over, but that's all we know. That is my computer's way of, my frame analysis software's way of saying, I know that this is a screen where the raid has ended, but it's not a kill screen because that's actually two different screens. But you can see that at that point, I go through and I scrub down to actually individual quarter of a second. And I look at each frame for a quarter of a second until I find all the kill screens that I can. I do this for a couple of reasons. I do this because, first of all, Landmark, when he's going through his kill screen, he often just clicks and he'll get off of it in less than a second. So I need that information in order to know how many kills were on this map or in this particular raid. Not to mention that because the raid parsing, the kill screen parsing is not perfect by any means, I just take the one, I end up parsing it out, and then I take the one that has the most kills. And I just call that one I just call that one the one that is the winner, the source of truth, as it were. And I only do 10 kill screens because any more than that is probably more than I need. And that is this video processing with Tesseract and everything leads me to a match that we know starts at 13:09 roughly and ends at 32 minutes, which is an 18-minute match. It's on customs, and he got 3 PMC kills. This is a match that I'd probably want to watch. So once this is done, it takes about 30 to 40 minutes to run on an 8-hour video. You're probably wondering, well, where do you go next? Where does it go? So that's where the web project comes in. So let's start that up. And the web project, as I mentioned, I wrote it in Blazor. I wrote it in Blazor because I kind of wanted a very fast, like, is it running? Are you running there for me? Let's see, localhost. Oh, there we go. So these are the instances of the actual raid. So you can see that it started to capture information on this one raid. It's got the path to the file, so I can click on the details, and I can actually see that I've got an embedded stream here, and I've got all the raids that I've actually processed. I stopped the process after it found its first raid because I just wanted to demonstrate to you how it worked. But if we looked at a complete one, which I have right here, this is a completely parsed file, and you can see that this is the same screenshot that I showed you earlier. These are all the raids that he's done with all of the number of kills, and I'm able to click on this button, and very simply, I just use the JavaScript API on the video object to just be able to seek to this raid, and now I can start it, and I can watch it. And you can see if I go down here, I've got some reserve raids, which makes me very happy because those are the raids that I want to watch. You'll notice here that there's a time code that starts completely at the beginning, and it kind of just ends here. Again, talking about perfection, not chasing perfection. The streamer, the frame analysis is not perfect, and nor is the algorithm that actually figures out, okay, what map is this? And in this case, it wasn't able to figure it out. This also happens because occasionally Landmark, oh, this is getting really bad. Occasionally Landmark will get stream sniped, which is when somebody, one of his audience members, joins the game and tries to interact with Landmark, tries to interact with him, which is generally speaking bad form. You just don't want to do that, but it happens. So sometimes he'll hide a screen if that keeps happening to him because he doesn't want it to keep happening. So in those instances, it's usually just fine. I don't need to know that. I don't need to see this raid. Or if I wanted to, I could write some code to very easily just take the end of this time code and just start here and have a rough starting time. Let's see. What else do I want to show you? I do want to mention the that I do as part of this. I write a good amount of tests in my professional life, but I didn't feel like these would have been important until I actually got to the point where I was actually going through and looking at individual images. So you see that I took individual screenshots right here of all these screens, and what I would do is I would use unit tests to iterate through and test each of these each of the screens to figure out, okay, which ones of these tesseract modes best gets the result that I'm looking for. So if you see here, if I run this test, or I actually think I already ran it, so I can just look here. Nope, it's not for some reason giving me a, well, I can just right click and run. Oh, it's like the IDE is like super slow. So what I did was I would try each of the segmentation modes in Tesseract. I'd give it an image and I would look at the result. And it was a lot of manual looking, but it was a lot of like, okay, this is how many kills is on this kill screen. So this is the computation that I should expect. And that ended up being really helpful because that gave me a lot of information. Like if I was parsing out the kill screen, and I know that it's a kill screen because it has this your kill list right here, I can look and see which segmentation mode in Tesseract would actually get me that information. So you can see your kill list here. So I ended up, a lot of the modes that I stuck with, the two modes that I stuck with the most for this were modes 4 and 6 that just happened to be the ones that worked the best, and 6 in particular for parsing kill screens. I believe 4 for individual strings worked out really well as well. So that is the project. That was what it was. So we had as much video information as we could, but we also had a lot of audio information. There's a lot going on inside of the game that humans can listen to and understand is a action thing. So that's where, or something that's useful. Landmark could be talking. I can take the talking or leaving, or we can put this through a machine learning model provided by Hugging Face and actually see if we can figure out where gunshots are taking place. So if I looked here, I found this one. I found this set that ended up working really well. And all it does is it basically gives, it doesn't do text to speech. What it does, it's like based on a small audio fragment or an audio fragment, what's the most likely thing that's going on in that audio fragment? And so what I ended up doing was running it through Python. So with the help of ChatGPT, I had this Python script that I wrote that would basically take the machine learning set that I had available, and I would give it a path to a file, and then I would say, okay, use FFmpeg. No, actually, I don't think FFmpeg is being used here. No, I just said split it up into half-second chunks, and let's process that audio file. So I'm going to play this, and you're going to see down here, there's going to be some output. So I think it's taking like a, it's like a, yeah, and that's all it does. I mean, it's every half second it goes through this MVP or MP3, and every half second it will tell me what's going on. Gasp, or sound effect, or speech in this case, because Landmark entertainers, streamers have to do a lot of talking to stay entertaining. But you can see that you can hear birds chirping. You can absolutely. Crunch is often associated with running because running has a very distinct sound. Clip clop as well is what they call walking. It does sound like a clip clop kind of thing. And so you can see it's going through, and I'm able to identify, not necessarily, it's not exactly perfect, but when it says crack, that's probably, it could be the crack of a whip that it's interpreting a gunshot as. But at some point, very soon, it would start saying things like gunshot or explosion. And those would be, or smash crash. Those to me are signals that something is going on in this raid, and I want to look at that piece of information, and I want to understand what's going on. And so I can capture those time codes, and then put them into my seeker so that I can skip to those parts. Again, it would have probably been better if I had gotten those time codes from the kill screen, but that would have broken two things. First of all, this was a learning project, and audio machine learning was something that I have an interest in, and I ended up learning quite a bit from it. I've learned quite a bit just doing my in professional experience, but also learned quite a bit just experimenting with this and figuring out which machine learning model ended up fitting the use case best. So I wanted to use it as a learning experience, and to again, I didn't want to keep doing the image parsing because it was just so. As I mentioned, I wanted to invest my time in other things. So that was that. So some weird challenges that I had to overcome as part of this project. First of all, originally I wrote it to just extract every frame. I knew that probably wouldn't work from a timeliness perspective, and I was right. It was taking way too long. So, of course, I had to shrink down the number of frames that I went. And luckily, Tarkov, getting into a match takes about 3 to 5 minutes. So I was able to be pretty aggressive and just look every 15 seconds, which is really nice. I had to balance accuracy and speed. This is oftentimes a lot of times when you're working with machine learning models, sometimes those are the balances, those are the trade-offs that you have to make. You can be accurate, you can be fast. You can be both, but you can't be both really well in most cases. So as I mentioned, I would only go down to analyzing a frame every quarter of a second if I really felt like there's information here that I'm going to quickly miss. But otherwise, I could be aggressive and just go 15 seconds, and that worked really well. Map detection. Map detection was only weird in that sometimes he would get a donation, and it would cover up that map that I was trying to see. In that case, this wasn't that big of a deal, though, for me, because all I had to do was just take the greatest in this list. All I had to do was just take the number of instances of customs and just say, this is the greatest one. But when I originally wrote my parsers, I was just assuming, the map is just going to be, I'm going to brute force it. I'm just going to assume the map is always going to be consistent. But when you're reading video information and audio information, oftentimes that's not the case. You can see that here. You can see that it's covering the map. So my original run for this, it was just one of those minor challenges I had to run over. So my original algorithm for this didn't work too well until I took that into account. So where do I go from here if I took this project elsewhere? Because right now it does require a lot of manual work for me. So the thing is leveraging the Microsoft cloud, or any cloud really, but Microsoft, because that's what I'm comfortable with. Ideally, this is what I would do, and this is probably the next step in this process if I really am but most of the time I'm watching them live, so I only do this sometimes when I'm really bored, and it was an academic exercise. But I would do it very similarly to how I've composed cloud systems elsewhere. I'd probably start by downloading the file, dropping it in Azure Blob Storage, sending in a message using Event Grid over to a storage queue. Message hits the storage queue and gets picked up by some kind of container service. And then it goes back and actually segments the individual RAIDs, saves it to a database, probably something like Azure Table Storage or something like that if I'm using Azure, and then put those individual RAIDs back into Azure Blob Storage. And then my web app is already deployed, so all I have to do is navigate to that, and then I can navigate to each of those individual RAIDs and have a good time. That is actually really well timed. So thank you very much for watching. This is a very different talk that I have given before, so I'm very eager for feedback. I don't have source code available yet because it's simply just an absolute mess. I'm working to make that happen, but if you follow this QR code, I'd really like to get your feedback on this talk. And there's a place to add your email. If and when I do open source it, I can send you that information. And then you can play with the project yourself. So I hope you've enjoyed this talk as much as I've enjoyed giving it and as much as I've learned from it. So that is all. Thank you very much.